Hi. One of the main nutrients in our diet is carbohydrate. Now, previously we looked at how carbohydrate is digested in the GI tract and absorbed into the bloodstream. Now today, in this video, we'll look in more detail at what happens to carbohydrate, what happens to the monosaccharides once they're absorbed into the bloodstream. How are they distributed across the body and how is that regulated? Now, consider the situation after a meal. After a meal, your blood glucose level will go up. And that increase in blood glucose level will trigger the pancreas to release a hormone called insulin. And insulin has two major actions. It stimulates the uptake of glucose into tissues. And it stimulates the conversion of the glucose into the storage form of glucose, which is called glycogen. And the consequence of those two actions is that blood glucose levels go down. Now, after a while, the decrease in blood glucose levels will trigger the production of another hormone by the pancreas, which is called glucagon. And glucagon is the exact opposite of insulin. So it promotes the breakdown of glycogen, and thereby it contributes glucose to the bloodstream. It helps maintain blood sugar levels during periods of fasting when no food is coming into the body. As a result, blood glucose levels maintained and the cycle restarts again. Now let's discuss in a little bit more detail the storage form of glucose called glycogen. And there are two organs in the body where we store glycogen. The first one is the liver. And basically glycogen is a polymer of glucose that resembles starch. Now, it is formed after a meal when blood glucose levels are high. But it's broken down during fasting when you don't eat, when you need to maintain your blood sugar levels. And that process of glycogen breakdown is triggered by glucagon. It leads to the release of glucose units into the bloodstream and therefore maintenance of a stable blood sugar level. Now what about the glycogen in the muscle? Now glycogen in the muscle has a very different function. Glycogen in the muscle cannot contribute to maintenance of blood sugar level. Glycogen in muscle is used locally inside the muscle where it is stored, and it provides energy for that particular muscle, particularly during high-intensity exercise. So if you would start running up the stairs, the glycogen that is stored in your thigh muscles would be used as an energy source. It would be broken down to glucose, and the glucose would be immediately used in the muscle cell to provide energy. So we can store excess glucose. We can store excess carbohydrate in the form of glycogen in muscle and liver. But what if these stores are filled up? What if we overconsume on carbohydrate, but these two stores are already filled up? Now, then we have the possibility to convert glucose into fat. We can convert carbohydrate into fat. So the body has that ability, which means that if you overeat on sugar, you can become obese very easily. The opposite cannot happen. Meaning we cannot convert fat into carbohydrate. And that's a serious limitation that especially has its impact during fasting because it causes our body to break down very valuable tissues to provide glucose when we're, for instance, in a state of fasting or famine. But overall, the point that I want to make today is that glucose metabolism is carefully regulated with the main aim to maintain stable blood sugar levels. And the reason for that is that the body can only function, the brain can only function if it gets sufficient amounts of glucose. So the body has developed an intricate mechanism that involves certain hormones, insulin, glucagon, but also others to maintain that blood sugar level. We can store glucose in the form of glycogen in liver and muscle, and we can convert carbohydrate into fat if we consume too much of it.